All right, it looks like we've got people coming in. It's great. So, welcome, people. Just, similar to our first session, just make sure if you have any questions, put that in the Q&A panel rather than in the chat. We'll actually answer those questions at the end of the webinar. All right, okay, I think we'll just get started. So probably just a recap of what we've done last week. So we've talked about the New South Wales energy saving scheme last week with a focus on measurement verification. And today we're going to do pretty much the same, but rather a focus on the Victorian energy upgrades, and also with a focus on the MIV methodology, which is the project-based activity. So yeah, this is the series 2 of our webinar series for the certificates and carbon credits introduction. And I'll just get started here. If you have any trouble viewing the past PowerPoint slides, just let us know. I think should be okay. All right, so yeah, we're going to cover today with a focus on VECs, which is called Victorian Energy Efficiency Certificates, and we'll talk about the project-based activity, which is MIV methodology, and also there's a multi-site arrangement within the same PBA, project-based activity methodology. There's also the deemed activities, which are focused on gas efficiency and also some lighting as well. We'll follow up with a list of case studies for the projects that we've done or that we're doing at the moment, and we'll finish up the webinar series with a Q&A at the end. Okay, so just a bit of introduction of what we do. So we provide 4 major streams of services to our customers, mainly large industrial and large commercial customers. And there's strategic energy sourcing, corporate energy decarbonization strategies, technical services including auditing, engineering, feasibility, etc., and also the certificates and carbon credits, which is going to be our focus for this webinar series. So yes, just me, myself, Alan here, and also my colleague Patrick, who's the General Manager of Certificate Operations at Northmore Gordon Enviro. And I'll just leave the slides to Patrick to continue.
Thanks, Alan. Welcome, everybody. Just a reminder as well, if you've joined a little bit late, got any Q&A, just drop them in the Q&A panel throughout the session, and we'll answer those at the end. So our journey so far, Northmore Gordon was founded in 2009 with a vision to drive energy efficiency and save energy costs for large energy users. We progressed rapidly and saw the measurement verification space as an area that we can add a lot of value, particularly for the larger energy users. In 2013, we had our first PIMA-V project in New South Wales, registered, New South Wales ESS. Moving through 2014, we registered our first project for ACCUs under the Emission Reduction Fund. And then moving on, we continued to grow our capability and experience, acquiring consultancies BCW and the Energy Integrity Services Division of NCBA in 2017 and 2019 respectively, which brought enhanced experience to our project team and a portfolio of projects. We registered our first VEU project in the summer of 2017, so really right out of the gate. 2018, sorry, right out of the gates there with the when the PBA methodology was introduced in Victoria. And at current, we've got over 1.5 million certificates under development across our portfolio. Now, undertaking any kind of efficiency project, there are a number of drivers to consider. Historically, drivers for businesses to undertake energy efficiency activities in particular is really around bottom line savings and increasing energy productivity. And these kind of targets can often be driven from site, from finance teams, or from headquarters to achieve targets, and not necessarily having any sustainability goals attached to those. There's also drivers about continual improvement to plant and site operations, which can involve right-sizing assets as the needs of a particular site change over time. Reducing risk in plant operations from maintenance and downtime from aging a plant is another driver to update your equipment with newer, more reliable plant. But we've certainly seen in growth over our journey that there is a growing demand for the environmental benefits of these efficiency activities. And even more recently, as companies looking to become more carbon neutral or reduce their carbon footprint, greatly increasing a focus around sustainability targets from headquarters. And one thing that environmental certificate programs, in particular, so the VEU in Victoria or the ESS in New South Wales or the Emission Reduction Fund nationally, is enable the environmental value of these projects to be realised through these certificate programs, attaching a dollar value, if you like, to the carbon or the energy savings that are achieved through these activities. And by giving that value, it gives increased driver for businesses to accelerate these efficiency programs. So there is very much a net benefit to businesses who want to partake in efficiency activities from either a energy productivity standpoint or an environmental standpoint to really bring forward those upgrades for these programs. So in Australia, there's two main classes of programs. There's the market-based programs, which are the Victorian Energy Upgrades, the New South Wales Energy Savings Scheme, and the Renewable Energy Target for LGC generation for renewable electricity. And we've got the direct action or the direct obligation style programs, such as the Emission Reduction Fund. It's also called the Climate Solution Fund, where the Australian government is buying abatement in the form of ACCUs. So there's two different mechanisms, but both result in giving a value and a financial incentive to undertake efficiency programs. So broadly speaking, there's two types of activities under all of these programs. There are deemed activities. Now these are simpler calculations around a set type of activities you can undertake that have predefined energy calculations. So it might be something you're familiar with in terms of a lighting upgrade, change to LED, where there's a calculation saying this is what the energy consumption was before, this is what the energy consumption is after. There's a calculation tool that you can use to calculate the number of certificates that you're awarded for that upgrade. The methodologies are often simpler. There's a quicker time to money as the compliance requirements and the evidence gathering requirements are simplified and streamlined and repeatable. But the trade-off is that the savings tend to be conservative and maybe averaged over across the entire state. So maybe your upgrade might be awarded more or less certificates than the actual energy savings achieved, but on average, it should be across the state, it should be about correct. But also it tends to be a bit conservative, so there's reduced risk of over-creating certificates. Now, these deemed activities are suited to smaller and medium-sized projects in terms of the energy savings that are achieved, where there's a deemed activity for that. So in Victoria, the most examples you might be familiar with would be boilers, lighting, and refrigeration style activities. In contrast to that, there's measurement and verification activities, which are technology neutral. So it could be any type of efficiency upgrade, as long as you can verify and demonstrate that there has been an energy saving, and Alan will go into more detail around how that's done. There's a more complex analysis required to achieve that. It takes longer to get a payback due to that analysis. So it can be between 12 to 18 months before the certificate value is realised. The compliance requirements and evidence requirements for each site can be quite bespoke depending on the exact nature of the upgrade that took place. The benefits are that the exact energy savings are quantified using statistically valid models, and this tend to be suited for projects with larger energy savings.
Thanks, Patrick. So, what is measurement verification? We have the international protocol, which is called the IPMVP. and it's intentionally recognized standard for quantifying and verifying either energy, water, or carbon savings. So it's either, in this case, we're talking about energy or carbon. And the reason why we need a MIV is, for example, we could have a site operating, 5 days a week during the baseline, but in the, in unexpected scenarios such as COVID, you might end up working more with the site or more or less with the site, with either more or less of the shifts, or you might actually end up, producing more production, for example, which could increase your energy consumption during your operating period. So in result, you might have, if you do a direct comparison, you might have done energy efficiency projects within a site, but if you just do a direct comparison, the energy consumption in your operating period might actually be more than your baseline period. So that's not really a good way of verifying the savings. So a measurement verification approach, in this case, good example here on the right, is that you do a model for your baseline condition, and then you adjust your, call it adjusted baseline, put that into your operating condition, and then the difference there in green between the adjusted baseline and the actual operating period, we call post retrofit, is the amount of savings. So in this case, the savings can be verified, and we have seen energy performance contracting companies being requested to do MNV, and in this case, we're doing MNV for this particular methodology under the Victorian Energy Upgrade Scheme to create certificates. So here's an overview of the VEU Victorian Energy Upgrade. The objective is to reduce greenhouse gas emissions from either natural gas or grid electricity in Victoria. So that's quite different to what we've covered last week. So in New South Wales, remember, it was based on energy. It was either based on natural gas or electricity energy conversion factor. In this case, it's the net carbon emission factor that's been objective from the Victorian Energy Upgrades. So the target has increased from previous years to 2021, which right now is 6.5 million certificates required in 2021. And it's been finalized that by the year in 2025, the target will actually increase to 7.3 million. So it's a gradual increase between this year and 2025. And because of that, this is obviously one of the reasons. Because of that, the VIC price has gone up quite dramatically in the last 6 months or so. So in the past 12 months, we've seen VIC being traded between 29 and 20 cents, and today's VIC price reached another record high of $51.95. So we've pretty much seen records every single week, since January this year. So the market is good. I mean, it's good in a way the VIC price is high, but in another way, pretty much means that there's a lack of activities happening in Victoria, which it should be of some concern to us. So talking about the activities on the VEU program. So today we're going to focus on PBA, which is here on the left column. So project-based activities. So it's a method that allows full creation of 10 years of carbon abatement discounted depending on the equipment. So that could be a persistence model, decay factor we call it, to apply on the equipment or the upgrade to be able to give you, say for example, a 9 years or 9.5 years discounted certificates rather than 10 years. PBA also allows a multi-site arrangement, so you could have similar activities happening in different sites or different locations, different NIMIs, and you can bundle them together into one project, and we call that a multi-site arrangement. In this case, it obviously save the admin cost, and also it just makes the whole thing a bit easier. there's the fuel switch activity is actually allowed in Victoria under the VEU program. It's either accepted between gas and renewable fuels or between electricity and renewables. So in this case, you could do, you could convert or you could reduce the electricity import into the site, replace that with renewable, such as solar PV, which we're going to talk about in a case study a bit later. Or you could just replace your natural gas consumption at a boiler, replace that with either biomass or biogas, which are both considered as renewable fuels. And this is actually accepted under the PBA. So on the right-hand side, you can see there's, we call it deemed, but neighbors benchmark rating is probably in the middle. So there's the deemed activity there. So with the neighbors benchmark rating assessment, you can do an annual creation of certificates based on your existing neighbors reporting schedule. It doesn't have to, so you could have done some energy conservation measures. It doesn't necessarily have to, result in a star improvement on your neighbors rating. But you look at the report, you can still claim certificates, and it's an annual creation. So you need to do certain things to improve your, improve energy efficiency at a site to be able to be granted certificates. And then there's the deemed, there's actually a new deemed methodology on the boiler gas efficiency upgrades, which also got a case study for that a bit later. So this includes replacement of hot water steam boilers or upgrades to burners, economizers, and control systems. There are certain things that's not included in the deemed activity. So we obviously urge you guys to have a chat with us if you have some projects under the belt. There's also commercial lighting, street and public lighting projects in VEU, which has been the focus of the past 5-6 years. Also, just a reminder, if you have any questions, just make sure you put that on the Q&A panel so that we can answer that Q&A session at the end of the session. All right, so what's a typical project step? So the project timeline for under the VEU program is actually a bit strict. So there's certain requirements, there's certain application requirement you have to go through before you commence your on-site work. So you could have done feasibilities or engineering design of the system, but before you get ESC or the regulator approval, you cannot commence the build on site. So we call it a scoping plan application, which is just talking about the site, what you're going to do about the ECM or energy conservation measure. And you also need to submit a project plan, which incorporates a measurement and verification plan, which could take some time to do. And this needs to be submitted to the regulator before you can commence the build on site. Once you've done your work, then that commence the we call it reporting period. So depending on your ECM, we might need to monitor for up to 12 months period of a normal operating period before we can commence writing up the impact report. And similar to the New South Wales scheme, you will have to do a external review. So that's called MVP review of the report. Submit the report to the ESC, the regulator. The difference is that in the Victorian program here, the regulator does the audit, so there's no external cost for the audit, but the process is still very onerous. So the audit itself could take up to 2 months before you can register your certificates, and only when the fix are registered, you can then trade the certificates for and get paid from the certificates. So yes, so I think we are one of the very few APs who actually we realize there's opportunities with solar fix. So there are certain reasons behind it. So obviously with LGC price not very good at the moment. Also because that in the fixed scheme or the PBA schemes, you can create the fix for 10 years for credit, whereas with LGCs, you can only do an annual creation. So basically, if you look at the graph here on the right, the fixed payments. So if you commissioned your system in 2022, you could get your fix in 2023, which we have 1 year monitoring period, and that's being full credit for 10 years. And so you just get one lump sum of payment rather than an annual creation from LGCs. And with LGC price being volatile over the next few years up until 2030, fix looks like it's a better option than LGCs. There are certain restriction requirements that needs to be met before you can undertake a solar fix project. So it must be, the project site must be in Victoria, and it cannot be a SEP site. So there on the VEU website, there's a link. A SEP site, is called schedule activity premises. These are all very massive sites in Victoria, which are exempted from paying fixed fees, so they are outside of the program. So you need to make sure that the site is not on the registry. It has to be an existing site, so we can do a baseline analysis of the site. So if it's a new build or a new development, then we can't even do a baseline. We can't even analyze that baseline. So we typically need 12 months worth of data to be able to see that baseline consumption or baseline. So we can actually create a baseline model for their existing sites energy consumption pattern. The solar system. So there's a minimum requirement that's set by us. That's really a trigger point to make sure that the project is now valid or is eligible or actually can pay for the MIV cost. So we set up at 200 kilowatts. Now with the fixed price being higher and higher, so we could actually discuss the minimum threshold. There is a maximum threshold that's dictated by the regulator, which is needs to be less than 5 megawatts, otherwise it becomes a solar farm. And in order to make sure that the measurement verification actually works, there should be no large changes in energy usage in the prior year and not expected in the next year after you commission your solar system. Obviously, we can do certain adjustment to make it work. So we obviously urge you guys to have a chat with us if you have a solar project coming up in Victoria. And also need to make sure that you understand the fix is created based on your imported electricity savings. So how much you've been saving on site rather than how much solar is being generated. So you could actually go to a site and put a very large system on the site, and majority of the energy or solar energy that's being generated is actually going back to the grid, and you wouldn't be granted a lot of fix, simply because fix is based on savings rather than generation. We talked about fixed fast payment, it's a lump sum payment, and also if it's the value of the fix is much more than LGCs. So yes, we'll follow up with a case study. So this is a project that's already commissioned, but we're still in the operating period of monitoring the system. So it's a 1.125 megawatt electricity of solar PV in a shopping center in Victoria. The solar generation of the solar panels are actually consumed 100% on site. There's this behind the meter BTM arrangement, and we set a boundary to include the whole site, which includes 5 different NIMIs from different locations of the shopping center. And we use PBA with measurement verification. The engine model was a little bit complicated. We realized that there's not only weather variable that we have to take into consideration, but because the solar generation is sort of according to seasonality as well, there's solar irradiance that we have to put into the equation. There's also depending on which day it is, the shopping center may be busier than usual, so we put in the parking tickets there to build an engine model as well. The savings were verified to be 1,665 megawatt hours grid offset per annum. and we create 14. We will create 14,000, roughly around 14,000 fix, which is full creation for 10 years. And yeah, because there's weather variable, in the equation, the project we need to monitor for at least 12 months for the energy consumption pattern, and therefore the total we're estimating roughly around 17 months for between when the project was commissioned and the payday. So just a quick comparison, you can get similar amount of, because in this case the solar consumption is 100% on site. You can get estimate number of the similar amount of LGCs, compared to fixed, but you wouldn't be able to get a full creation of those LGCs. You can only do annual creation of LGCs according to 2030. All right, so that's the second case study here. So we took part in the Comanche train lighting upgrade back in 2019, and in this case, because the trains are locomotive, the moving locomotive, so we have to do sampling with estimate of the main. So we do a random sampling and take the carriages being randomly selected and go on to each of the carriage, and then we chuck the meter on, get voltage and current, and we use estimate of the main to create certificates in this case. So the verified savings is roughly around 2,000 megawatt hours a year, and the annual carbon abatement is about 2.2 kiloton of CO2 emission. And because it's a sampling method estimate of main, there's no weather variable in the modeling. We achieved a less than 1 year payback. Obviously with sampling, etc., took a long time before and after, but we still achieved a less than 1 year payback to pay to the customer with a certificate value of $570,000 back to Metro Trains. So this is a biomass boiler upgrade. This is a typical fuel switch upgrade. So this is starting in to the west of Melbourne, and there's they replaced the existing boiler system with a 3 megawatt biomass boiler, and the boundary is set to be the whole site. So there's natural gas consumption at the whole site, including the biomass delivery docket. So there's no weigher or weighing bridge on site, unfortunately. So we have to take the biomass delivery dockets as the data for modeling purpose, which was proven to be challenging, but we end up getting a pretty good model as well. So this is a regression modeling that we've done. So we did regression model on the natural gas consumption, which has a correlation with weather and site production, and the same goes for the biomass consumption in the operating period. So the verified saving is about 19,500 gigajoule annual, and we create around 10,700 fixed for creating of 8.9 years for the biomass boiler. The net payment to the customer was around 380K plus GST, and because in this case there's weather variable in the equation, we end up, the total time they spent for the MMV and also the review, the audit, took a total of 14 months between when the project was commissioned and the payday. And then there's the non-fuel switch boiler upgrade at a council pool. So it's simply replacing the existing conventional boiler with a more efficient condensing boiler. And we set a boundary at the whole site, which is the natural gas incomer to the site, and the boiler room, which is also the electricity component of it. So we use the PBA with measurement verification with using regression modeling, and edge model was between the energy consumption at the boiler versus the weather components. And the savings were verified to be 4,131 gigajoule natural gas per annual, and the net payment to customer was 41,000 plus GST. And because in this case, again, this is a site or we establish a boundary that has correlation with weather. We have to monitor both summer and winter of a typical year. So in this case, it's roughly around 17 months for the monitoring period. And Patrick will talk about a comparison with a deemed methodology.
Yeah, thanks, Alan. So comparing like a similar upgrade, had you done that particular upgrade using a deemed boiler replacement methodology, you can see there that the payment is significantly less. It's about $9,000 versus the $41,000 using the M&V approach. There is, however, a much faster payback, 2 months versus sort of the 14-month, 17-month payback time. Now, some of the main differences in this case is you'll notice that the boiler was actually increased in capacity, even though it went to a more efficient condensing style boiler. The absolute capacity of the system increased, which then has a bit of a negative effect on the VEECs because you only really credit the lower capacity, the 470. So you're not necessarily capturing that, and that comes out in that sort of averaging kind of process that the conservative and averaging process used in the deemed calculations would have worked against this particular project. However, the evidence requirements are a lot lower to collect the evidence, really only needing photographic evidence and specifications for both the upgrade and the baseline boilers. I guess another thing to note for those who joined us last week or have looked at the New South Wales Energy Savings Scheme, you can see here the comparison is about a quarter for the deemed versus the M&V approach in terms of the value that's returned. The ESS program actually favours gas efficiency activities a little bit higher than Victoria. It comes down, I guess, fundamentally because Victorian is a greenhouse gas saving program, whereas New South Wales is an energy saving program, so gigajoules in this case. New South Wales actually awards a bit higher. So we looked at a case study last week at a similar level of energy savings, but resulted in almost double the dollar value returned to the customer in New South Wales. So just something to be aware of. New South Wales is still a bit of a hotspot for gas saving activities. But as we'll come to, Victoria has some other benefits.
Yeah, it's a huge difference there, 41 versus about 9K.
All right, so like we said, in Victoria, the grid emission factor is changing for the purpose of the VEU program. So historically, the emissions intensity of the Victorian grid has been taken to be at 1.095 tonnes of greenhouse gas equivalent per megawatt hour delivered. But as has been now finalised in the recent Victorian regulatory impact statement, for the purpose of the VEU program, the grid emission intensity is taken to be decreasing over the next 5 years. And all these numbers maybe are not exactly the grid intensity at that time, they're 10-year forward estimates. So the grid intensity taken in 2022 is a 10-year average of the grid intensity from 2022 to 2032, to give you an example. You see the first change stepping down from the 31st of July this year, stepping down from 1.095 to 0.9546, and then stepping down again in January next year to 0.81. So that's the first, so 2 steps in this first year, and then annual steps down, stepping down to 10-year average of 0.393 in 2025. Now, as Alan mentioned earlier in the presentation, the VEU target, the number of VEECs that need to be created each year, is increasing to 7.5 million by 2025. Now, if all of those VEECs were coming from electricity saving activities alone, you'd see that the actual energy savings that need to be achieved to achieve that target is going to be almost 3 times greater, coming from an emissions factor of 1.095, dropping down to an emissions factor of 0.393. So what does that mean for the VEEC program both today and over the coming years? So right now, for example, solar VEECs is a really hot activity. Really for the next 12 months before these emission factors kick in, there's a great opportunity to use solar VEECs because they're electricity saving activities. So any activities that are saving a lot of electricity use will get credited at a higher level now than they would if they're undertaken in a few years' time. But what that does mean, though, is we can see a bit of a trend and a bit of a pipeline of activities that in a couple of years' time, there's going to be an increasing value of fuel switching or electrification activities. So any activities that reduce natural gas use and replace with lower emission grid or will be favoured more in the coming years. So you can see a bit of a pipeline. If you've got activities or ideas for projects in the coming years, there will be potentially greater incentives for gas fuel switching or electrification activities. So that's something to keep in mind going forward. In terms of minimum threshold, this is a bit of a guide, so absolutely talk to us if you've got particular opportunities in mind. Comes down to what are the types of activities you're taking. If you're looking at something like a PBA or a measurement verification approach, there is kind of a fixed cost. It does take a fixed amount of effort to start a measurement verification process. It does take a bit more analysis. So there is sort of a minimum threshold where we think it becomes financially viable. And that's about 100 megawatt hours savings per annum, or gas equivalent in gigajoules, which translates to about up to 1,000 certificates forward created over 10 years. So that gives you, if you've got a project that achieves at least 100 megawatt hours of savings per year, it's a viable candidate for M&V. So certainly talk to us. PBA multi-site, again, if you've got similar upgrades occurring at multiple sites with different NIMIs, certainly talk to us. We can talk about that. That can definitely impact, reduce the administrative load, so we can certainly help capitalise on the value of those adding together. Deemed methods, I mean, really, there's really no cap. We're happy to look at any deemed activity. So some of the ones we've talked about that directly compare with measurement verification, such as boiler upgrades, or some of the deemed lighting upgrades. Certainly talk to us. We can look at you. If we can't offer you a good M&V solution, there might be a good deemed solution that'll be better value for you for that particular upgrade. And of course, there's the benchmark rating or the neighbours activity, which again, any kind of size neighbours, we're happy to have a look at to see if we can create certificates from your neighbours' regular activities. Just a reminder, we've got a final part of this webinar series on Friday. So same time, 3 p.m. And we'll be covering, focusing on the Nationwide Emission Reduction Fund and what opportunities and methods are available under that for your projects. So final words, that's it for our presentation today. If you've got any questions, please drop them in the Q&A box. We'll go in and answer those. We've got one question here. Where can we find the recording from last week's session? Our first part, that's easy. We'll be posting those on YouTube shortly. We'll be sharing a link over the next week once we've completed the session for all three. We'll be posting those up so you can go back and have a look at them on your own time. Do we have a similar program as VEECS for large solar systems above 200 kilowatts in New South Wales? Or is the only option LGCs? Alan, do you want to answer that one?
Yeah, look, I think, thanks for the question, Seda. The only option in New South Wales is LGCs as of now. So I need to point it out that the New South Wales government went through a consultation late last year about the introduction of fuel switch activities into the ESS program. So there is definitely a possibility that large-scale solar system, as in fuel switch, could potentially be introduced in New South Wales ESS program, but at the moment, there's none at the moment. So yes, LGC is the only option in New South Wales at the moment.
All right, I'll just also add to that, I think, Alan, you alluded to, certainly with the fuel switching in New South Wales compared to Victoria, because New South Wales is an energy saving based program as opposed to a greenhouse gas saving program. There needs to be a net reduction in energy use for any kind of fuel switching activities in New South Wales. Again, the regulator might be changing that, but again, that's one of the main drivers that doesn't enable those projects to be really viable under the ESS program.
Yep, definitely. So looks like we don't have any more questions, which is good. We might actually end up a bit earlier today.
Well, I've got a question for you, Alan, before we go off. What do you think are some of the biggest traps people have found with M&V projects? Where do you think people get caught out, and what can you do to sort of reduce those problems?
Well, you're probably talking about risks. Yeah, so I guess the main risk with M&V is, I guess there's certain requirements on the different schemes, but in this case, under the VEU PBA scheme, there's not there's we call it effective range criteria, which means when you do a model, you look at, say, for example, you look at monthly model for 1 year period, you've got 12 data points, and you build a model looking at your maximum of your independent variables. For example, if you do a simple regression model between energy and site production, and if you dramatically decrease your site production in a single month in your operating period, you wouldn't be able to claim certificates for that month. So there's something to watch out for. So that's why we mentioned earlier, if you are, that there's certain things we have to watch out for. And if the customer is looking to implement something different, or they're looking to have a major change happening in next year's operation, or they're looking to, say, relocate to a different site, which could really jeopardize the entire project, there's just a potential risk that certificates might not be available. So in order to make sure that this is actually a valid option for the customer, you always want to check with the customer that they're not looking to do anything, or even if they're looking to do something dramatic, or they're looking to do something next year, they might actually implement another ECM. They might relocate to another location. They might, develop a new factory next door, which might be under the same NIMI. And all these things, should really communicate to us so that we can make some adjustment. And there are certain things that we cannot make adjustment for, such as we call it non-routine adjustment. It's not allowed under the Victorian program. So if the customer suddenly change the for example, heated floor space with a boiler, and the boiler system is boundary, then there are just certain things that we can't really adjust, and there's certain risks that we need to take.
Thanks, Alex. Another question for you is how early should we, if you've got a project, how early should they engage an AP such as ourselves to go start this process for an M&V project in Victoria?
Yeah, just going back to that slide earlier that we talked about. So that's the project steps slides. I think it's sorry, this one here. So yes, so as you can see, there's certain things that we have to do. So there's the scoping plan application and project plan application. We have estimated in the past, because of due to our past data, it typically takes about 4 to 6 weeks for a application process to be submitted to, between the application is submitted to the regulator and when the regulator approves the application, with much of the delay coming from the regulator. Now there's the scoping plan application, which is really straightforward, and we should actually submit it as soon as we can. And ESC has dedicated to approve it within 2 weeks, which has been the case from ESC, no doubt about it. But what's really challenging is the project plan, which has to incorporate a management verification plan. With that, we need to understand the site, request some data from the site, and do some modeling for the site operation. If it's a shopping center or a retail shop, it's relatively straightforward. So we just need a NIMI data or natural gas data. But if you're talking about a factory or a large industrial site where the processes may be more complex, we will need to do dig a bit deeper when we do the M&V plan. So that could typically take another 2 to 4 weeks or so. So in total, if you allow between 4 to 6 weeks, depending on the complexity of the project to us, we should be able to get a project plan submitted, a scoping plan approved by the ESC, which means you can then commence your build on site.
Great, thanks, Alan. So I guess the key message there is really engage as early as you can, and we've got information. So we've got time to get data from site if it's required, and to go through those regulatory processes before breaking ground on site. It looks like we don't have any other questions, so we might wrap it up there today. Thank you very much, everyone, for joining today. And we look forward to seeing you if you're available to join our third session on Friday. And you'll be able to sign up via the links we've sent previously. So thank you very much, everyone. Enjoy your afternoons.
Thanks, Patrick. Cheers. See you guys.